Hello everyone, my name is Dr. KCH Apparao, working as an mechanical work, working as an associate professor in mechanical engineering department. Okay, in previous class we discussed the combustion process. Uh, Combustion process. What is the basic principle of the combustion process? Uh, what are the types of combustion? We discussed in previous classes also. Now we'll see combustion process or combustion in IC engines. Mainly combustion in SA engine we'll see. So spark ignition engine, how the combustion takes place in spark ignition engines. Now we'll see, okay, at the end of this course, students should be able to classify the injection and ignition systems, fuel injections and ignition systems, to pretend the application of combustion chamber. So combustion chamber designing is very important for the combustion processes. We'll see. Okay, combustion in engines. Combustion is nothing but the process of burning a fuel air mixture. Okay, air fuel mixture. Why? To release the energy in the form of heat. Okay. So then, which is then converted into mechanical energy or mechanical work. So this is nothing but combustion process in a internal combustion engines. Okay, due to this combustion process in internal combustion engines, chemical energy is converted into mechanical work. Okay. So in last class we already discussed this one. Combustion, two types. One is normal combustion. Second one is the abnormal combustions. If the combustion takes place inside the cylinder, those cylinders, those engines are called otherwise external. Those engines are called external combustion engines. Okay. If the combustion takes place inside the cylinder, those engines are called internal combustion engines. The combustion takes place outside the cylinders, those engines are called external combustion engines. So external combustion engine, example steam engines, okay, locomotive engines, and internal combustion engine is just like IC engines, spark ignition engine, diesel engine, petrol engine, all are the internal combustion engines. Now we'll see combustion process in SI engine, combustion process in C engines. SI means combustion takes place with the help of spark plug. So spark ignition. So that spark plug gives the spark. Due to that spark, ignition takes place and combustion takes place. Okay. So those engines are called as SA engines, spark ignition engine. Another type is C engines. Here, the air fuel mixture combustion takes place by compression of the fuel. Compression of the fuel by piston. So due to this high compression and high pressure and high temperature, those air fuel mixture ignites self ignition occurs throughout the chamber. So this type of engines are called C engines. C engines, best example is the diesel engines. Okay. SI engine mainly petrol engines. Okay. So in SI engine, the commonly used fuel is petrol, volatile fuel. So that vaporizes easily. It means this petrol mixed with the air, and automation also occurs rapidly and vaporized with the air, and burning, it means combustion takes place easily. So ignition, the spark plug here, this is the external device by using this spark plug. So ignition takes place. Ignition in air fuel mixture occurs. So these are the SI engines. Next to characteristics means faster combustion due to pre-mixed fuel and air, because air fuel mixture due to atomization, the fuel particles are overlapped with air. Due to this proper air fuel mixing, so faster combustion will occur. So next one, knocking also. Knocking is the just like abnormal combustion process or abnormal combustion. So it is a very drawback. So the knocking also occurs if the combustion happens too rapidly or unevenly. So proper mixing and sufficient air fuel air fuel mixture. It means simply charge, uh, providing of charge in the combustion chamber. So these things are also very important. Next one, compression ignitions, mainly simply called as diesel engines. Here fuel used as just like diesel, less volatile, ignites at high pressure and temperature. So due to high pressure and temperature, it means due to high compression, diesel ignites selfly. Ignition means heat is generated during high compression of the piston. Okay, so high compression of the air fuel mixture by piston. So due to high pressure and temperature, automatically ignition takes place in the cylinder by the help by selfly. Okay, by the effect of high pressure and temperature. So next to combustion characteristics. Combustion depends upon the quality of the fuel automation. Automation is nothing but convert the just a conversion of big particles of the fuel into small particles. Those small particles are ionized with the air, so that air fuel mixture burns effectively. So next to diesel knock. Diesel knock occurs during rapid combustion of fuel air mixture. Okay. So next, now we'll see combustion process. If the combustion does not take place, what would be happen? What is the graph of that engine? We'll see that one also. In IC engines, internal combustion engines, if the inlet and the exhaust valves are closed and piston moves from bottom dead center to top dead center, so that time compression takes place. You know that the compression means, so this is the cylinder, top dead center. This one is the piston connected to connecting rod. So this one is the bottom dead center. Okay. So BDC. Okay. So if the piston moves from bottom dead center to top dead center, it means this is the compressing. So the air fuel mixture, so which is entered into the cylinder. So that air fuel mixture is compressed by compression stroke or by the piston. Okay. Suppose at the end of this compression, by the help of this spark plug, if it is SI engines, spark ignition engines, ignition takes place and automatically high pressure and high temperature, peak pressure will occur. Suppose if the combustion is doesn't take place, it doesn't uh, happen. Okay, the curve is like this one. It means the high pressure. It means in the compression, uh, temperature and pressure of the fuel increases gradually, like this one. Okay, so this is the compression stroke. At the end of the compression, if the combustion does not occurs, does not take place, then so it means at the end of the TDC again piston moves from the top dead center to bottom dead center. So again means so if the piston moves from top dead center to bottom dead center, automatically the vacuum, the volume will be increases, automatically the pressure will be decreased. Okay, the pressure rate like this one, this pressure gradually decreases. So this is the curve if there is no combustion, if the combustion doesn't takes place. So this is the curve like this one. This curve is simply called as motoring curve. Okay. If the combustion doesn't takes place in the engine, you will see this type of curve. So it means pressure gradually increases in compression stroke, and in expansion the pressure is gradually decreases by increasing the volume. Okay. Suppose if the combustion takes place, so due to this combustion, high pressure and high temperature will release. Okay. So high pressure, high temperature releases. So these high pressure, high temperature, it means a peak pressure will occurs like this one. The pressure in the cylinder reaches to peak position like this one. Okay. If it is good and normal combustion process, this peak pressure occurs after the TDC. After this is the just like compression stroke means this is the, it means the piston moves from bottom dead center to top dead center. At the end of the top dead center, okay, combustion takes place. Okay, so if the combustion takes place, automatically high pressure will release that peak pressure. So this is the curve of the pressure we can take. So the pressure will occurs very near to TDC after the TDC. So that is the beneficial. Okay, so we'll see what is the importance of that one also. So this is the curve. At point C, we'll see peak pressure. Okay. So the combustion does not takes place during this the pressure. So that is the curve, motoring curve. If the uh, combustion takes place, the curve is like this. So high graph, high peak pressure graph like this one. Then in expansion stroke, gradually decreases. We'll see here also same process. Suppose according to theoretical engines means we know that one. Suppose this is the engine. So this is the TDC piston. So BDC. Okay. This one is the engine. You know that according to theoretical engine means so suppose it is a 4-stroke engine. The power cycle in the 4-stroke engine completes in 4 strokes. First stroke. So first stroke means suppose the piston moves from the TDC to BDC. Okay. So the piston moves from TDC to BDC. In this case, if the piston moves from TDC to BDC, the crank wheel or connecting rod moves 180 degrees like this. Suppose BDC, BDC, TDC, TDC to BDC. So this is the suction stroke. Okay. So this one is the suction stroke. So next to the piston moves from BDC to TDC. You know, like this. So this is the suction stroke. So next piston moves from BDC to TDC. If the piston moves from BDC to TDC, the air fuel mixture will compress. The compression takes place like this. Okay. So this is 180 degrees. This is the 180 degrees. Okay. So compression. In the compression, the pressure will increase. Pressure of the air fuel mixture will increase. Okay. So at the end of the compression, combustion takes place. At the end of the combustion takes place. So due to combustion, high pressure and a high temperature will take example. So due to the spark, help of the spark, combustion takes place. Due to this one, the pressure increases very rapidly. This is the peak pressure. Okay. So at the end of the combustion, so due to this high pressure and high temperature, the pressure truss forces the piston from TDC to PDC. Again, the piston moves from top dead center to bottom dead center. Okay. So it means uh, the volume will increase. So volume will be increased automatically. This is the expansion stroke. Okay. So this one is the expansion stroke. This one is the 180 degrees. Again, in last stroke is the just like exhaust stroke means in which the uh, unburned fuels, otherwise the smoke will be scavenged from the cylinder head. So like this. It means 360 plus 360, 720 degrees crank angle movement. So, it means for completion of one cycle, one power cycle, the crank wheel or the flywheel, the crank will rotates 2 revolutions in 4-stroke engine. So according to theoretical value, 180 degrees movement of the crank that takes suction. Next 180, that is the compression. Next 180, so that is the expansion. Next 180, that is the exhaust. So these are the angles, but practically these are not possible. So this graph shows the theoretical engine. Theoretical engine means the pressure range increases rapidly at 180 degrees of piston, like this one. Next stroke, it increases gradually. So the graph should be according to theoretical value. The graph should be in compression. The pressure will rise in at the end of the compression. So that takes combustion. Combustion, ekdam, so the pressure will increases. In expansion, next one is the gradually pressure decreases. So this should be the graphical representation of theoretical pressure. Crank angle diagram. So because uh, but practically, so it is not possible. Okay, because uh, the piston moves continuously from top dead center to bottom dead center, bottom dead center to top dead center. Okay. The piston will not stop at any dead center. So when the piston reaches to top dead center, again it moves to from top to bottom. Okay. So in this movement, the combustion takes place doesn't not at a single point. It takes place after the movement of uh, just like it means after the combustion also takes place in the movement of piston in downward direction also. So in compression piston moves in upward direction. In expansion, the piston moves in downward direction. So when the piston in expansion stroke, the piston moves in downward direction. So after end of the compression and beginning of the just like expansion, the combustion will complete. Will complete means high pressure and high temperature will occurs. Mainly the peak pressure appears after the TDC and very near to TDC. So then gradually decreases. So this type of curve we can observe. Okay. So now we'll see what is the combustion process in SI engines. Okay, we'll see here there are three stages or three phases or three stages of the combustion process in SI engines. Okay, what are those phases? We'll see, or what are those stages. Okay. So this is the diagram of pressure and crank angle movement in angle data. Okay. So this is just like compression stroke, and this one is the expansion stroke. In between compression and expansion, it means at the end of the compression, combustion takes place. Okay, so we'll see. So this is actually in theoretical value. The combustion occurs at the end of this point, means at TDC point, top dead center point, but that is not possible. It is moving continuously. So after TDC, just like after compression means the piston moves from top dead center to bottom dead center. That is expansion. In the expansion also the combustion process will end. It means before end of this combustion starts. After after compression, the piston again moves to downward direction, means expansion stroke. So beginning of the expansion also it continues and it will stop. So the combustion process. So it means when the piston very supposed to near the TDC, it starts and complete just the piston just like moves from top dead center to bottom side. It means the starting of the uh, expansion stroke also it will continue. Okay, so we can't see at particular point the pressure doesn't rise them vertically, so it gradually increases like this one. This type of graph you can see. Okay. So we'll see different stages in SI engine. The stage one is called ignition lag. Stage 2 ignition lag means this is the AB, the distance between AB that shows the ignition lag. Next to B to C. So B to C, this is a perfect combustion process in which we will see flame propagation, extension or movement of the flame from spark point to end of the cylinder. Third stage after C means we can see after burning. After burning. So that is simply called as after burning. It means after combustion also some uh, uh, type of burnings we can see. So we'll see first of all what is ignition lag. Next what is flame propagation. Next one is the what is third phase or third stage. What is after burning. Okay. Suppose to achieve the advantage of high pressure generated during the combustion. Okay, so which is beneficial for the efficient SI engines. Okay, so it means the peak pressure should occur after TDC, and very near to TDC. So that is the very beneficial. Suppose the piston, it means if the peak pressure would occur before TDC, it means high pressure. The released high pressure automatically pushes the piston from top dead center to bottom dead center. But here, before TDC means that is in compression stroke. Compression stroke means the piston moves from bottom to top. So it is in the compression stroke means piston is in upward direction. So when the piston is moving in upward direction, the high peak pressure, this pressure moves in downward direction. Piston moves upward direction and pressure moves downward direction. So this type of pressure is not beneficial. Okay, so that is a negative force that creates the negative force because the piston is moving upward direction. the combustion pressure which is released in the combustion process that pushes the piston in downward direction. So this is not required force, that is the negative force. But after TDC, the piston moves in downward direction. If the peak pressure also just like appears also created at the after TDC, so it means the peak pressure which is released in the combustion. So that one also moves, pushes the piston downward direction. The piston also moving in downward direction. So this is the required force. It means the piston is moved rapidly. So in this case, okay, the piston. So this is the beneficial force. So which one is the beneficial means to achieve the maximum advantage of high pressure. To achieve the maximum advantage of high pressure generated during the combustion. So this peak pressure should be after TDC, because after TDC the piston moves in downward direction. Okay, if the peak pressure occurs after TDC, that pushes the piston in downward direction also. Before TDC means the piston is in compression stroke. The piston is moving in upward direction. Okay, that upward force, the peak pressure, downward force, these are the negative forces. After TDC means the piston also moves in downward direction. Released pressure also moves in downward direction. So automatically this is a useful uh, process, useful pressure force. Okay. So that is if the peak pressure is after and one more is drawback is if after TDC peak pressure should be uh, created. That is the required parameter. And also, but if the peak pressure is after and far from the TDC, if the far from the TDC like this one, okay. So this time also just like not preferable, not useful, because less time. It means if it takes more time after TDC, so the piston at the time the piston also moves in downward direction. Okay, so the impact of the pressure doesn't works on piston properly. Okay? That uh, that lateness, the pressure, the peak pressure, effect of the peak pressure, and just like pushing of the peak pressure and the piston is not beneficial here. Okay, so due to this one, efficiency of the engine will reduce. Okay. So two conditions. One is it is not required to create the peak pressure before TDC. That is very important. Next, it is also not required to create just like create peak pressure after TDC, but but far from the TDC. That one also not required. So which one is required? So the peak pressure should be released after TDC and very near to TDC. So that is the beneficial to get the more efficiency of the engines. Okay, first we will see what is ignition tag, first phase. First phase we will see stage 1, ignition lag. Ignition lag. So the difference between A and B. So A point shows the also we can call as the point A and point B. A is the starting of the spark or spark occurrence of the spark plug. So due to the spark plug, that gives the spark. Okay. Due to that spark, the chemical reaction will occurs between the spark 2 and fuel. Okay. So to combustion to start the ignition at point B or combustion at the point B, it takes some time, very less time, 0.001 second. The time in the time, so it means there might be a chemical reaction between the just like spark to air fuel mixture. You can say at point B first. At point B automatically full fledged. It means combustion will start, ignition will start, and the ignition will start automatically. pressure rising of the pressure will increases. So from point B to point C, rapid pressure will release. Okay. So C shows the peak pressure. Okay. So at point B, first rise of pressure detected and the actual curve differs. Here gradually increases, pressure increases, but from B to C, we'll see rapid increase of the pressure. Okay. And the first pressure rise at B, that is known as the ignition lag, the difference between the A to B. So that is called ignition lag. So in this ignition lag, uh, just like this is the duration between the starting of the spark and just starting of the ignition combustion. Okay, it is just like represented by crank angle theta. Uh, Next, ignition lag is also known as the preparation phase. Preparation of ignition. Okay. Preparation phase during which spark will release due to the spark plug. In the spark plug, you know that this is the inside electrode is there in the spark plug, and the outside electrode also like this one. The high voltage energies passes from the inside electrode to outside electrode. So in this case, the air gap between these two electrodes are ionized. Due to this space, electrons will start. This just like gives this spark in between this one. So this spark helpful to take the ignition in the air field mixture. So ignition lag is simply known as preparation phase during which spark and chemical reaction takes place. So due to this spark and the surrounding air field mixture, there must be a chemical reaction between the spark and the air field mixture uh, will start due to this effect. So for this starting for this reaction, it takes some time, very less time, 0.001 second like this one. Okay. So this time is nothing but ignition lag. So in SA engines, combustion ignition lag is very important. Okay. So it may be as small as for getting the more power. If it is less time, ignition takes place, combustion completely occurs, and compression takes place rapidly. So automatically high pressure will release. That pressure pushes the piston from the top dead center to bottom dead center. So this one is so next phase two is the just like a B to C. So from B, ignition takes place, combustion starts at one point very near to spark plug. That this flame propagate like this one, like this one. Okay. So this flame propagates and reaches to end point of the cylinder. So in this way, remaining fuel which is occupied in the cylinder, so will comes into combustion process, or combustion takes place in the remaining portion of the cylinder also. So the flame which started at point B gradually just propagated from point B to point C. So up to C, it means end point of the cylinder. So in this case, high pressure will release, peak pressure will release, this rapid pressure will release. The time duration between B and C. So B is the combustion starting point. C is the peak pressure, highest peak pressure point. So this is nothing but flame propagation. Flame start at B and it is propagated throughout the combustion chamber from point B to end of the cylinder. Okay. So just like in this way, just like the flame propagates from spark plug to surrounding combustion chamber. So in this way, ignition takes place and combustion takes place. The most of the heat is generated during this phase. So in this phase, we will see very high peak pressure. Normally, just like a spark will occurs at point A approximately. So the angle of the crank is 0 to 35 degrees before GDC. before TDC. So this is the TDC, this one before TDC, spark occurs. Okay. So as speed vary, the spark timing should vary also. Peak pressure values, just like next to peak pressure, uh, just the angle is very 5 to 10 degrees after TDC. After TDC. So combustion starts before TDC to after TDC. Combustion starts in end of the compression, and combustion and just like ends in expansion stroke. So we have to identify that one also. Okay. Next, stage 3. Stage 3. Okay. Uh, so this is the after burning, after combustion. So peak pressure gradually decreases. Some C to D. So this is the after combustion phase. Okay. Theoretically, we can say that combustion should be completed at point C. Theoretical values. Okay. Uh, at maximum pressure. Okay. But actually, combustion will continue after C also during expansion stroke. Okay. So that is also that is the burning. It may be due to uh, one is two of the fuels, rich mixing, high fuel rate and high air percentage. That is one reason. Due to high charge and high density. So after combustion also some time, mm, after some time, combustion will continue. So that is called after combustion process. So after 10% of it, so in this one only 10% of heat will see. Okay, this is the peak pressure. Peak pressure will gradually increases. Only 10% of heat only will add. So you can see the graph of it. So AB shows the ignition lag and B to C shows the flame propagation. After C to D shows the after burning. If there is any unburned particles and over mixing and over charge rate, charge volume, if the volumetric efficiency is high, that leads to this type of after burning. So next, we'll see what are the important points. Important points are highlighting points in these three phases. In the first phase or first state, that is the ignition lag. Okay. Just I'm repeating the highlight points. After this spark plug, this ignition lag starts, and that generates the spark. Okay, after plug, you know that spark plug will generate this spark. Okay, so this spark, due to this spark, chemical reaction occurs between the air fuel mixture to spark, and automatically ignition takes place. Okay, after the spark plug generates spark, so there is a brief uh, delay, some delay. So like EAP. So this is the TDC. In compression, pressure gradually increases. So this is the peak pressure C. A in the compression process, A, point A. So next to this is the B. At point A, you know that the spark plug gives the spark, starting of the spark. B is the just like it's starting of the ignition. A to B, in this distance, the chemical reaction occurs between the spark to air fuel mixture. Okay. So during this lag, uh, ignition lag, the air fuel mixture near the spark plug undergoes free frame chemical reaction. So that takes the chemical reaction. Next, this phase is influenced by factors like fuel composition of the fuel, air fuel mixture composition, and fuel composition. So these are very important. Next, air fuel ratios also. Air fuel ratios, pressure, and the temperatures. These are the important parameters which are influencing the uh, just like this combustion process. So next to second one, you know that flame propagation phase, the rapid combustion. A flame kernel forms here at B point, and it spreads from B point to spark plug to outward of the just like cylinder, okay, like this one. Spark start like this one, propagation of the fuel. So ignition, propagation ends at the end of the point. So expand outward as the turbulent flame front. So due like turbulent flame front. So this phase involves rapid oxidation of the air fuel mixture, releasing significant amount of the energy in the form of pressure. So the speed of the flame propagation is depend upon the turbulence. If it is turbulence, you know that laminar flow and turbulent flow. If it is turbulent flow, the the speed of the flame propagation is high compared to laminar flow. Okay. So mixture quantity. So homogeneous mixing of air fuel, that is one also important. Next, engine geometry, size of cylinders. So these are the important parameters which are influencing the flame propagation. The pressure and temperature in this cylinder rise significantly increases. Okay. So those things also very important. Next to after burning. So after burning is the less combustion process. Just like near the end of the combustion, the remaining unburned fuel particles. Okay. So in just like in pockets, so in the form of pockets, that continues to burn. Okay. So this phase ensures complete combustion of the fuel, but may contribute less uh, heat releases. Okay. So less heat loss and emission also. Okay. So next, key factors which are influencing the combustion also, mainly air fuel mixture ratio. The air fuel mixture is occurs by the help of the carburetor. You know that one. Carburetor gives homogeneous mixture of air fuel. Okay. So that is the stoichiometric air fuel ratio, that is 14.7 to 1 per gasoline. So that is the optimized air fuel ratio to ensure complete combustion. Uh, over uh, over air fuel ratio, that one also leads to problem. Less air fuel ratio, that one also mm, leads to problem. So an optimized level of air fuel ratio should be needed for the proper to ensure the complete combustion, proper effective combustion process. Rich or less mixtures impact flames. So these are the impacts the flame speed. So mixing of air fuel also very, very important. If we give the high density of the fuel and less density of oil, it means less ratio of the air. So that one also leads to some problems. Okay. So rich and less mixture also impacts the flame speed, efficiency also, emissions also. Next, compression ratio. So that is very important. If the compression ratio increases, automatically efficiency of the engine increases, but that leads to some abnormal combustion takes place. Higher compression ratio improves thermal efficiency but increases the likelihood of knocking. So knocking is just like very problematic drawback. Next, spark timings also. Proper spark timing ensures that peak pressure occurs lightly after the TDC. So we know that the peak pressure should be after TDC, very near to TDC. Okay. So if the timings vary automatically, the pressure, the high pressure develops very far from the TDC, that leads to problem. Okay. Next, turbulence is very important. Cylindrical turbulence enhances mixing and flame propagation due to uh, turbulence of fuel. Proper mixing will occur, that leads to good combustion process. Okay, so turbulence improves the combustion stability. Next, to fuel property, just octane, very important for the just like petrol. Mm. So octane indicates the resistance to knocking. So if you increase the octane rate, automatically you can reduce the knocking problem. So fuels with high octane number performs better in SMS. Next, the challenges. That main is the knocking. Okay, knocking problem. So that spoils the surface of engine parts, like the surface of the piston, like just like surface of the internal cylinder surfaces. Knocking leads to loss of power, potential engine damages. Incomplete combustion also that leads problem. Produce the unburned hydrocarbons in the form pockets. Okay, so and carbon monoxide also CO and shoot and increase the emissions, over emissions, overshoot, and over smoke will occur. Next, the thermal efficiency is very important parameter. High heat losses due to high heat high heat losses reduces the efficiency, okay, requiring better combustion chamber design. So designing of the chamber is very important for the enhancement of the thermal efficiency. Okay, these are the references to know more about this combustion process. Thank you for listening to this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.